I want to explain how to calculate power. And this is the simple version of it, right? Power literally is the rate at which work is done. So if you have a more powerful elevator motor, you can lift the elevator faster. You can lift it at a faster rate. If you have a more powerful car, it can speed the car up at a faster rate. Okay, that's what we mean by power. Okay, and this is the traditional definition of it, right? And that is work. And that's, of course, in joules, and then this is the time it takes to do that work, right? And that's going to be in seconds, right? And then this is our power. Okay, this formula here is kind of an interesting formula, and I can derive that formula, right? Because if it's power is work divided by time, work could be force times distance divided by time. And of course, distance divided by time is velocity, right? So this is force, right? And then that's velocity. Okay? And this is like, if you think about those exercise machines, I gotta let my dog in here. If you think about those exercise machines that you sit on, right? This is how they calculate your power output, right? Is that they measure the drag force, say if you're pedaling, and then they read your RPMs, right? And that's going to be your power output. Okay. Okay. So let's do an example problem here, right? A person does 48 joules of work in 6 seconds. Well, power is work divided by time, right? So that's 48 joules divided by 6 seconds, right? Well, let me think about it. I get my calculator here, right? That is going to be 48 divided by, that's 8 joules per second. Now, watt is another way to write joules per second. Watt is another way to write joules per second. Watt is another way. Oh, it's watts. You guys aren't laughing. I can't hear you laugh. Gotta laugh harder. Okay. Yeah, it's 8 watts. You can just write it like that. Okay. So a watt, 1 watt, is equal to a joule per second, right? And that makes sense, right? It's how many joules of work you do in 1 second, right? Okay, that in turn is a Newton meter per second, right? There's newtons, meters per second, right? And then what is that? A Newton is what is that? A kilogram meter per second squared, because F equals ma, right? Times meters divided by seconds. All right. So a watt is that a Newton meter squared per second to the third? That's crazy. Kilogram meters squared per second to the third is what it is, if you're curious. Okay, most people aren't that curious. Alrighty, so let's go to the next one here. Okay, we've got another example. Okay, I actually had a 23 window van that could go about 25 meters per second top speed, not 60 miles an hour, but it could go about 55. Okay, what is the force resisting its motion? So if you've ever wondered how powerful a horse is, well, here it is. No, I'm just kidding. When we talk about horsepower, right, this is the conversion. That's how many watts it is. In Europe, they tend to rate engines actually in kilowatts and horsepower. Well, kilowatt, of course, just means 1,000 watts, right? Okay, so I can rewrite this thing, right? Power is force times velocity, right? Ta-da, right? And so let's see, force would be power divided by velocity, right? But I can't use horsepower. I've got to convert that to watts, right? So the power is 30 horsepower, right? Times 745.7, and this is really watts per horsepower, right? Almost got that wrong. Okay, so 30 times 745.7. That's a lot of watts. You know, if I wrote that in 22,371 watts, right? That looks like a lot more than just 30, right? Okay, so now I can go ahead with this, right? 22,371 watts, right? That's Newton meters per second, right? Divided by, what is it, 25 meters per second. Of course, the meters per second go the way of the bison, right? And so I'm going to divide by 25. And I get 894. The force is 894.84. Newtons. It's newtons. It's in newtons. It's in newtons, it is.